This video is going to cover the 2011 free response questions number 4 through 6 with my solutions and grading. So question 4 is the question dealing with inference. I can tell that because I have evidence at the alpha equals 0.01 level. I can see units, so that tells me it's quantitative data. I have one variable and I have two groups. They're independent groups, so I'm looking at a two-sample t-test here. So laying out the 4 steps. Okay, that's how your inference question is going to be graded in this point. You'll notice on the rubric we're talking about section 1, 2, 3, and 4. This is very generous in my mind. They give you essentially, partially, or incorrect. Typically for the inference, it's usually just essentially correct or incorrect, but opportunity to earn some partial credit here, which is nice. So for step 1, or section 1, hypotheses, mu sub A minus mu sub B is equal to 0. My alternative, mu sub A minus mu sub B is is less than 0. Remember, for means, you're always using your parameter mu. That's the only thing that should ever go in your null for tests of means. Okay, so you can notice on the scoring guideline here, you could also write for your alternative mu sub A is less than mu sub B. That would also earn essentially correct. Okay, as far as scoring that goes, it's essentially correct if you state your hypotheses with the correct comparisons and you define the parameters. Defining the parameters is, you don't need to do sentences like they do in the rubric. This is sufficient and it states that in there. So that's going to earn me essentially correct for section 1. Section 2, for the conditions, you'll notice that I need to do 3 things in order to earn essentially correct. Identify the correct test name procedure by name or by formula. We've done it by name. Checks for random assignment to treatments, and checks for normality. So if you do 2 of those 3 things, P, 1 of those, or 0, I. So I have random subjects were randomly assigned to the treatments. Okay, got that component. You'll notice they don't talk about independence or independent groups, which bugs me, especially this independent groups, because you have 2 independent groups, so I'd expect that that's on there. And it's been on rubrics in the past, so that definitely needs to be on there. We are going to assume both groups are independent. I also need to assume that one person's cholesterol level is independent of another's. For the nearly normal condition, I have raw data, so I plug these into my calculator, did zoom 9, created some histograms here. Make sure you label, this is group A, pre minus post cholesterol, frequency, just every other here on the x-axis. For your calculator, you can get those values just doing zoom 9 in your calculator and hitting trace. So both histograms are unimodal. A is skewed to the right, B is roughly symmetric, so therefore I'm going to assume the population distribution is approximately normal and the central limit theorem is going to apply. Okay, so I have those 3 things that they discussed. You'll notice here, oh, I have the name of the test here. I have a 2-sample t-test. So 2-sample t-test, the random assignment, and the nearly normal condition for section 2, that's going to earn me a B. Okay, you're going to notice when they're showing their sample solution here, you have the 2-sample t-test, the random assignment. Okay, the small sample sizes you need to check, so they checked. They said a slight skewness. They're going to proceed with caution, kind of. You could say that in there. That would be appropriate. Okay, step 3, getting into your mechanics. As far as earning credit for your mechanics, this is what it's going to look like. Your test statistic and your p-value have to be calculated correctly. If you have one of those 2, p, none of those, I. So looking at their solutions, test statistic is going to be negative 1.62 degrees of freedom, and your p-value 0.062. Depending on rounding, it could be a little bit different, but should be right in that ballpark as far as earning credit. So you'll notice I did the difference in the parameters was 0. The difference in the sample statistics or sample means was negative 6.2. Just getting that value, those values are right here. They gave you some summary statistics, 10.2 minus 16.4. For the standard error, that formula I need to know is on my formula sheet. Okay, I'm dealing with 2 samples, and I'm dealing with the difference in sample means. Remember, this one we're never using. We never pool for 2-sample t-test. So I'm just using this, the variance or the standard deviation squared over the sample size. So that's where I'm getting the 7.66 squared divided by 10 and the 9.4 squared divided by 10 square root of that. Just doing a 2-sample t-test in my calculator to get this test statistic, and that's going to give me my corresponding p-value as well of 0.062 along with my picture. All right, this is going to earn me essentially correct. I have the correct test statistic. I have the correct p-value. Okay, so that leaves me with my conclusion. So if we take a look at that, section 4 for the scoring for step 4, what do we need? Essentially correct. If you have a correct conclusion in context and providing justification based on the linkage between the size of the p-value and the conclusion. Okay, so since the p-value is low, it was 0.062, we failed to reject the null. Okay, I immediately realized I've made a mistake here, so I'm going to earn incorrect. The p-value is not low. It was 0.062. The p-value is high. My decision is right, but this is incorrect. So the p-value is high at the alpha equals 0.05 level. We fail to reject the null. And then take a look at what I'm doing here. There is weak evidence, and I'm going to use the context from the question. There's weak evidence that the cholesterol drug is effective in producing a reduction in the mean cholesterol level beyond what is produced by exercise and diet. I'm just going to take the context from the question. Okay, that'll take a lot of the thought out of it and make sure that I'm using the correct words there. So that's incorrect in my mind. Okay, so I have 3 essentially corrects. I have 1 incorrect, which is embarrassing, but that's why you want to make sure that you're really conscientious of checking little things, because that just cost me a point for no reason at all. So I have 3 E's and an I. That's going to earn me 3 points on this question. Okay. Like we talked about in class, good strategy here. If you're running out of time, you make up that p-value, you write a conclusion. If you really have no time, you just do your hypotheses, make up a p-value, and then write up your conclusion. Okay, question 5. This deals with linear regression. Nice question. We'd be lucky to get something like this on your AP exam. Okay, in part A, you just need to be able to take this computer output and write the least squares regression line equation, which is pretty simple skill in my opinion. We definitely need to be able to do that. The one thing you got to be careful of is little things that can cost you credit here on a question like this. So part A, it's essentially correct if you give the correct equation and provides the variable names with context, or uses a modifier such as expected, predicted, or estimated, or hat symbol. That's the one I worry about you forgetting. So remember, this is always going to be your slope. This is going to be your explanatory variable. And sometimes they'll put the response variable above the table. In this case, they didn't. So I have wind velocity and electricity production. So it's going to be electricity production hat, or predicted electricity production, equals 0.24 times the wind velocity plus the constant or intercept, 0.137. So I have both of those components in my answer. That's going to earn me an essentially correct. Part B, they want to know how much more electricity can I expect when the wind is 25 miles per hour versus 15 miles per hour. Well, I have this equation here I can now substitute into. Substitute in the wind is 25 and 15. And I can see that I'm going to get these 2 values. And I notice another simple mistake that I've made that is going to cost me credit here. Okay. As I take a look at this, it's essentially correct if they use the correct slope or the slope value in part A, and you need 3 works. 3 components. You're going to show your work, arrive at an answer, and provide correct measurements units, amps. Okay, so you'll notice here I switched these 2 values. When the wind is 25, that should actually give me 6.1 amps. So I've not given the correct, I've shown my work. I've not arrived at the correct answer, but I have units. Okay, so I've done 2 of these 3 components correctly. That's going to earn me a P. All right, and you'll notice in their answer here, you could have just taken the difference times the slope to get 2.4 amps. Okay, part C, this is a very simplistic skill. You either kind of know how to do it or you don't. What proportion of the variation in electricity production is explained by its linear relationship with wind velocity? This is talking specifically right about r squared, writing r squared in context. So 87.3% of the variation in electricity production is explained by the variation in wind velocity. You'll notice I said variation in wind velocity. That's how I talked about it in class. Actually, I'd encourage you more so to use the vocabulary and the words that they have here. Either way would be essentially correct, and talk about its explained by the linear relationship. So in part C, essentially correct if your response is 0.873. I'm surprised no work needs to be shown, no context, so That's going to earn me essentially correct. So I have essentially correct there. Okay, for D, is there statistically convincing evidence? Tells me there's a test here. I have quantitative data because I have units, I have miles per hour, I have amps, and I have two variables. Immediately once I have two variables, this is going to be a regression slope t-test. So this is chapter 27 stuff, so some inference coming at you. Okay, so let's look at the grading rubric. As far as this goes, okay, essentially correct. Three components. Gives the correct conclusion based on the test for the population slope, correct p-value and test statistic, and linkage for your conclusion. Okay, so you'll notice for my null and alternative, my null is beta sub 1 is equal to 0. There's no linear association between the two variables. My alternative, beta sub 1, is not equal to 0. So that means there is some kind of linear association between the two variables. Conditions. They were already stated to be reasonable in the context of the question. So I still need to say that, and I need to name my test. So conditions met, use the t-model with degrees of freedom equal to 23, because my sample size was 25 minus 2 is 23, for a regression slope t-test. So my parameter is beta sub 1 equals 0. My statistic is the slope, which is b sub 1 is 0.24. Statistic minus the mean over the standard error. How did I get that? Just from the table. That's my slope. That's my standard error. That's going to be my test statistic. That's going to be my p-value. So there's my test statistic. There's my p-value. Remember, this is a two-tailed test, so when you're writing the notation, it's 2 times that. How did I know it was greater than? Because I have a positive slope. Okay, my p-value is essentially 0. So for my conclusion, since the p-value is low at the alpha equals 0.05 level, we're going to reject the null. There's strong evidence of a positive linear association. This is key, because if you're rejecting the null and it's two-tailed, I want to know, is it a positive or a negative linear association, not just there is one, between the wind speed and the electricity production. I can go further and say generally as the wind speed increases, so does the electricity production here as well. Okay, I have the three components here. I have the correct conclusion. I have a p-value and test statistic that is correct. And I gave linkage as far as to why I made the decision that I did. Okay, and you can see here in the rubric, the null, the alternative, there's your test statistic, p-value, and then their conclusion. Okay, so this is going to earn me essentially correct. So I have 3.5 points. Typically, almost always, it's going to be rounded down. So I'm just going to follow that here. It's kind of a case-by-case basis, to be honest, when we're grading as far as rounding up or down, but just assume it's going to be rounded down in almost all cases. So that's going to earn me a 3 on question 5. Okay, taking a look at question 6. Remember, this is the question that's weighted more than every other question. You want to spend about 25 minutes on this and do not leave it till last. All right, your goal, earning at least 1 point here, at least 1 point. Okay, so for part A, what we have is we're just constructing a 99% confidence interval for P. Well, P, that's proportion, so I have a 1 proportion Z interval. All right, so all I need to do is calculate that in part A. Let's take a look at the rubric first. As far as grading goes. Okay, section 1 and 2 are based on part A. So 2 sections come from part A. Section 1 is essentially correct for these 3 components. You identify the correct inference procedure, that's your 1 proportion Z interval. You check the randomness condition and the large sample size condition, which is what we call success failure condition. So let's take a look at that. So it was stated to be a random sample. I'm checking my conditions. Independence assumption, one student's response is independent of the next. 10% condition, this 9600 is less than 10% of all US 12th graders. That's definitely reasonable. Success failure. Here's the deal, guys. If you don't know whether to put the hat or not, leave this out, to be honest, and just put the numerical part, 9600 times 0.28. If you know P, use P. We know P here. So I have the 2688 and the 6912, both of which are greater than or equal to 10. So that is met. Conditions are met. I'm going to use a normal model for a 1 proportion Z interval. So I have those 3 components. I have my inference procedure, I have my randomness condition, and I have, what's the third one? The large enough sample size. So that's going to earn me an essentially correct. Right there. So literally, guys, right there, that's a point. I've earned 1 on this question, which is going to earn me a little over 3 points on my composite score, which is huge. 1 point on question 6 is worth a little more than 3 points, 3.125 points. Okay, almost 10% of what you need to earn a 3 here. Huge, huge, huge. Okay, section 2. What do we need to do in section 2? Okay, it's essentially correct if you do the following 2 things. Calculate the interval correctly and interpret it, including a confidence statement and correct parameter and context. Okay, so if we take a look at what they do, there's their confidence interval, and then we're 95% confident the interval contains the population proportion of all US 12th graders who would answer this correctly. So I need to get the correct interval and then talk about the conclusion in context, including the parameter here. So mechanics, 0.28 plus or minus. This is just my critical value for 95%, square root of P times Q over the sample size. Keep in mind for every single confidence interval on your green sheet here, you have your statistic plus or minus your critical value times the standard deviation, which will always be standard error, but I have one proportion right here, single sample, sample proportion. So those formulas are on there to help me out. I just did a 1 proportion z interval in my calculator to get this value. It's n. N was obviously 9,600. X is the number of successes, 2,688. Remember, if that's not an integer, round it to the nearest integer. And confidence level is 99%. Okay, conclusion. We are 99% confident that the true proportion, there's me talking about the parameter, of all US 12th graders that would answer the question right is between 26.82% and 29.18%. So I've done those 2 components. That's going to earn me essentially correct. Right now, that's 2 points on this question, which is 6.25 composite points. Again, you typically need somewhere in the high 30s, low 40s to earn a 3 for a composite score. So earning 6 points on this one question is huge. Okay, part B. This is where it gets a little awkward, as these questions always do. You'll notice here, section 3 is consisting of parts B and C. Usually there are going to be 2 parts clumped together with a kind of a simple calculation and then taking it a little bit further. So let's look at part B. Okay, you needed to fill out this table, all right? I wrote it neatly on the other sheet, so I'll flip over to that in a minute. These have to add up to 1. So if this is K, this is 1 minus K. If there's 4 choices and I guess at random, I'm going to get the question right 25% of the time. I'm going to get it wrong 75% of the time. I'm just going to multiply across branches to get these values. You'll notice K times 1 is K times 0 is 0. So when I do this, I'm going to multiply 1 minus K times 0.25, and I just left it in this form. And then 1 minus K times 0.75, I left it in that form. Okay? In part C, it says, based on your completed tree diagram, express the probability in terms of K that a randomly selected 12th grader would answer the question correct. So, probability of correct. Well, there's 2 options here. They know the right answer, so the probability they got it correct is K. So we're just looking at the answers correctly. And the answers correctly here, I did the distribution here, is going to be this part. So I have K plus 0.25 times 1 minus K. Do some simple math there. I'm going to end up with 0.75K plus 0.25. Okay, so that's B and C. Let's look at grading that. That's going to be section 3 on your rubric. 2 components. Completes part B of the tree diagram in terms of K, so if you did that correctly, and part C adds the correct results. Okay, so 2 things. If you did them both correct, it's an E. If you did one of the 2 correct, it's a P. So I've done both of those correct. For parts B and C combined, that's going to earn me essentially correct. Again, every single point on question 6 is worth 3.125 points overall. Huge. So I'm up to 9.375 points just on this question alone. Okay, and moving to the last part, this is where it gets really awkward, and they're kind of throwing something out there and then seeing what you can do with it. Okay, question D. Using your interval from part A and your answer to part C, do another confidence interval. Well, we haven't really done a confidence interval based on another confidence interval in a conditional probability tree diagram, so they're just seeing what you can do. So, equates the expression from part C to a numeric estimate, uses the endpoints from part A to calculate a reasonable interval, and interprets the resulting interval. So, let's take a look at their key. Okay, so what they did is take the probability that they guessed and got it correct, set it to equal to the lower bound of your interval in part A, and to equal to the upper bound. So then you have your lower and your upper bound of this new confidence interval. Okay, you'll notice I did not do this in any way, shape, or form. Okay, so I did conditions. We're doing another one proportions interval. It doesn't even talk about checking conditions. I got my lower bound and upper bound from part A, and I substituted it in. However, I substituted it in for K. That was my problem. I didn't substitute it in as what it should be equal to. And then I generated my confidence interval based on that. And then I said we're 99% confident that the true proportion of all US 12th graders that would get the question right is between these percentages. Okay, so as far as the scoring goes, I'm not sure what I'm going to earn here. Equates the expression from part C to a numerical estimate in part A. So I didn't set it equal. I did not do that. Uses the endpoints to calculate a reasonable interval. I did use the endpoints. I think I did that, and I interpreted it correctly. All right. So I did two of the three things. I believe this would earn a P, maybe an I, definitely not an E. Okay, so I have P, that would be 3.5. That's going to round down. I've earned a 3 on this question. All right, so that's questions 4 through 6 for 2011 free response. Hopefully you guys found this helpful. See you in class.